Alright, hello everyone. I am back with a new Chinese FM transmitter. This is the 50 to 70 watt FM PLL stereo transmitter. It is the upgraded version of the old yellow one that I featured in my last video, the 30 watter. It's more like a 35 watter. So this one claims to range between 50 and 70 watts, depending on the frequency. You can see it looks a fair bit different. The board is blue. There's a different MOSFET in there. It has a different screen. This one has a USB interface right there. It's got the buttons on the front there, and they use the wrong color code for that, but that is the line input right there. This features the QN8066 chip, which is the second best FM transmitter chip. You can see that in my previous video where I reviewed all the different Chinese FM transmitters. This transmitter was not contained in that review, I don't think, because it's a newer one. I hadn't known about this because it's not on eBay, it's only on AliExpress. Which is kind of odd, because usually you find everything on AliExpress on eBay somewhere, but this one was not. So, if we take a look at it, we can see, there we go, RD35 HUP2 is what it looks like. Yeah, it's a little bit, part of it is a little bit off there, but it's the RD35 HUP2. So this is a UHF transistor, I believe, and it's designed for 35 watts. So the fact that they're running all the way up to 70 watts doesn't really seem like a good thing, but we're gonna find out. We'll see if it works, and then I am going to do a burn-in test on this thing. I'll have this thing hooked up to the dummy load for a while and see, you know, if it keeps working over time. You can see they actually soldered a little copper bar onto the bottom of it, because it didn't even come with like a heat spreader, so they actually put their own on there. A possible problem right there is that they soldered the two tiny little metal tips on either end of the device, but underneath the actual device itself, I don't think there's any solder under there, like connecting the copper bar to the thing. So I don't know if it's going to have problems heat sinking because of that, but we'll find out. So what I've got here, I've just got adapter going right here, going into the bird meter. We've got 100 watts, 50 to 125 slug in there. The dummy load, and I've got an RF tap on the dummy load, and that is then going into the spectrum analyzer, the Riglal 815. So, and then a power supply right here, 12 volts. I've got going through this cable right here. That could end up being problematic because it's pretty thin. So hopefully it doesn't overheat, but without further ado, let's give it a go. Alright, we're in. So this is what it looks like. I've got it set to the low end of the band right now. Okay. Everything seems to be okay. We're drawing 8.6 amps. Okay. At 12 volts. Let's check out the bird meter. Okay, this is at 100% power. You can see the SWR is good. Here we go. Well, alright, so not quite as good as I would think, but we're only running 12 volts even, so that's not too bad. So we're getting 46, I guess. So not too bad. But if we look on the spectrum analyzer, we're going to find that, well, take a look at that. Yeah, Not too impressive. Got a lot of phase noise. At least I think that's called phase noise, that noise that's right around the carrier. I don't know the proper terminology because I'm not like an actual RF engineer. But it's got a lot of noise, as you can see. And I'm a bit surprised by this because this chip normally has a little bit better phase noise. It always has a hump. Even the QN8066 has a hump around the carrier like that. But this looks worse than on the 30-watt version of this. So we're getting 5 dBms. Okay. 5 dBms, 87.9. So let's take a closer look here. It looks like, right, so 35. I mean, that's not very good. Let's zoom in a bit because sometimes, you know, things change a bit. So I'm gonna go to trace. Let's do average. Okay, so it's right about there. Oh, that's 44. Okay, so I guess when you do average, it's actually not that bad. It's at... Alright, so we're at 44 right there. Okay. So let's span again. See, this is interesting. It's like when you span, see, now it looks like it's a lot worse. It's at 37. So this is probably a more accurate representation. I'm not entirely sure. But yeah, so we're at 4 dBm, or 5 dBm, essentially, and 37. Okay. So, not very, very good, but let's check out one last thing. We're going to zoom in very far. Now, see, this is interesting. When we're zoomed in incredibly far here, actually, that's not quite enough. Let's do more. Okay, so you can see the carrier itself is actually not that bad. It's relatively narrow. And the MPX has no harmonics going out, which is really good. Because on the BH chip, you get like this porcupine thing coming down here, which really isn't good. This one looks cleaner in terms of the close-in spurs. The really close-in spurs, I mean, yeah, no, they don't really exist. I mean, we got Pilot and MPX and stuff, but we don't have stuff going out here. So that's good. So close-in spurs on this thing, very good. But in terms of the noise surrounding the carrier, not very good. Alright, but not terrible. I mean, is it usable? Probably, but not ideal. Clearly a cheaper transmitter, and that noise must be getting somehow amplified more by the chip. I mean, by the amplifier, because the chip itself is a bit better than that. The chip on its own. So, some of that must be coming from the amp. So, let's see here. Let's see what happens if we turn the power down. It's not listening. Come on. Oh, there we go. Wow, you have to press it each time. It's weird because you don't have to press it each time for the frequency. Okay, we'll go to 50% power. Okay. Let's see what we're getting here. looks more or less the same. Now we're getting 4.2, so that's definitely not 50%. No, it's not. We're still getting 42 watts. So at 50% power, it's basically the same thing. They clearly didn't figure out how to do that properly. But let's just let's span out a lot here, because at this point I want to see if we're getting a bunch of noise and stuff. And no, I'm not seeing it. Not too bad. All right. I mean, well, nothing worse than before. So let's go down more. And go down to 10, I think. I'm gonna have to do drastic because it didn't seem to affect it much. Okay. So at 10% we get nothing. Alright. Well, yeah, I mean, nothing. Maybe a tiny little thing there. Alright. So 10% doesn't do anything. Or, fine, 21. Okay, so with 21 we have a carrier. I can't see exactly the dBMs because it's not lined up properly. Alright, so we're getting 20, roughly, a little less. Alright, so doesn't necessarily look worse. 0.6 dBm. And I mean, it doesn't really look any dirtier than it was before. Like, you know, on the 30 watt transmitter, when you turn the power down on the screen, you get a lot of crap going on in the signal. This one doesn't seem to be too bad. Let's do a little less. I want to find the cutoff threshold, because at 10 it wasn't doing anything. So let's find out where that cutoff is. Let's try 12. Okay, so we're getting something at 12. Yeah, it still looks good. No spikes or anything weird. So almost 7 or 8 watts, I guess. Yeah, okay, so this one, that's a good thing about this one. This one doesn't get a bunch of noise in the signal when you turn the power down, like the other 30 watter did. See? We still have a pretty good spectrum, no harmonics. See? I mean, very clean. The only downside to this spectrum is the noise that we have. Yeah, so as you can see, there's nothing there other than the signal and that, you know, noise skirt thing. Okay, so phase noise is worse by a little bit, but it doesn't have worse, like, it doesn't have spurs going up when the power is down low, so that's a positive. 10,000 years later, 10.5 million years later. That's badly designed. I don't know why they did that. The frequency works, but the power does not let you adjust it by holding it in. You have to press each one. 446-ish, almost. We're gonna pump up the volume all the way here. No, that's too much. That's too much. Alright, 13.9, so we're really pushing it there. Almost 10 amps. Alright, so the noise looks higher, but that's just because the signal itself is higher. It's probably going off the screen a little bit. Alright. What are we getting? Okay, so we're getting just barely under 60 watts. Alright, so this really should be advertised as a 60 watt transmitter. It's doing about 60 watts. And this is at the low end, where they said that it would do 70. and it's doing 60. So not too bad. I'm gonna turn it down because I don't know about doing this here. I'm gonna turn it down. Yeah, 12.5 is good. I think that's what this MOSFET is rated at. So we're gonna do that. Yeah, so not much higher than before, as you can see, just barely 50 watts. Okay, so this thing isn't mind-blowing, but it's alright. So one last test we're gonna do here is we're gonna change the frequency to the top end of the band. We haven't done that yet. Okay, 108, right? Oops, alright. Alright, we're going to 108. SWR is a little bit lower. Here's our amperage at 108. Okay. Carrier moved a bit. It looks like at 108 we do get a tiny bit of noise right there, but not too big. Anything else? No, it doesn't look like it. Okay. Yeah, so 38 watts. Okay, so I mean, that is the 38 watts here. Not really any different than the 30 watt version, the orange version. So I guess if you're using 108, no point in getting this transmitter if you're using 108. Or you know, 105, 108, something like that. Don't bother getting this one, get the other one. You'll save money and, you know, you're gonna have the same performance anyway. Because if you run the 30 watt at like 13.5 volts, you'll get the same amount. You'll get this amount. So, and the downside to this transmitter is that big amount of phase noise there. It's got a lot. Despite the fact it's got the Quintec chip in it, the QN8066, it still has a lot of phase noise. Let's just do one more thing before I quit the video. Alright, so I just turned it off. Okay. Not too bad. That's pretty warm. Oh, yeah. Wow, okay, this gets very hot. That's strange because on the 30 water, the filter barely gets hot at all. Like, it doesn't get hot at all. This is hot enough that, yeah, I can smell it. I can smell this right here. So, I don't know, they should have made these coils bigger. They're about as big as they are on like a 15 watt transmitter, so these should be bigger for this kind of power. They are hot. Otherwise, feels great. Nothing bad. Alright, so that's about it for the video. Hope you enjoyed it. So I guess I would say, if you're looking at this transmitter, if you're going to use above 105 megahertz, you're going to use the upper end of the FM band, don't get it. If you're going to use the low end of the band, maybe you want to get it if you want to pump out as much power as you possibly can. If that's your goal, then get it. But it does have a lot of phase noise, so definitely not the best transmitter, even though it's got the QN8066. So yeah, that concludes this video. Hope you enjoyed it, and have a good rest of your day.